Dear students, in 2021, Cbse has made some major pattern changes in question papers. In this video, I am going to explain the changes in Class 10 Mathematics question paper and a detailed discussion of newly introduced case study questions. For standard and basic question paper, the time allowed is 3 hours and the maximum marks is 80. Both the question papers consist of two parts, part A and B. Both part A and B have internal choices. Part A consists of two sections, section 1 and 2. Section 1 has 16 questions of 1 mark each. Internal choice is provided in 5 questions of 1 markers. Section 2, the most important newly introduced 4 case study questions. Each case study questions has 5 case-based subparts, and examinee is to attempt any 4 out of the 5 parts. Question number 21 to 26 are very short answer type questions of 2 marks each in part B. Question number 27 to 33 are short answer type questions of 3 marks each. Question number 34 to 36 are long answer type questions of 5 marks each. Let's see the internal choices. Internal choice is provided in 2 questions of 2 marks, 2 questions of 3 marks, and 1 question of 5 marks. So in this video, I'm going to discuss the case study questions of standard sample question paper 2021 provided by Cbse. Question number 17, 18, 19 and 20 are the case study questions. All 4 case study questions are compulsory. Of the 5 subparts. Let's see the 4 case study questions of standard question paper. The first case study question is in question number 17. Question number 17, which is in part A, section 2. Let's see the question. The diagrams show the plans for a sunroom built into a wall of a house. The 4 walls of the sunroom are square, clear glass panels. The roof is made using 4 clear glass panels, trapezium in shape, all the same size, 1 tinted glass panel, half a regular octagon in shape. You can see the trapeziums here. So these are the 4 clear glass panels. This is the first trapezium. And this is the second one. And then the third one. And the 4th trapezium. Like this, 4 trapeziums are there. The roof is made using 4 clear glass panels, trapezium in shape. So let's see the 5 sub-questions of this case study question. Question A of 17. Find the midpoint of the line segment joining the points J617 and I96. So it's very easy question. You can use a direct midpoint formula. All of you know the midpoint formula. It is x1 plus x2 by 2, y1 plus y2 by 2. Based on that, when we do this one, you will get a 6 plus 9 by 2, comma 17 plus 16 by 2. That comes like this: 15 by 2, comma 33 by 2. That is option 3 is the right answer for the first question. The midpoint of the line segment joining the points. Let's see the second question. It's question number 17b. The distance of the point P from the y-axis is. The distance of the point capital P from the y-axis is? So look at the point capital P in the diagram. So this is the point capital P that is at a distance 1, 2, 3, 4. That means it is clearly 4 units from the y-axis. So the point P, so this distance what is asked, that is 4 units from the y-axis. So that is the answer for the second question. The distance of the point P from the y-axis is 4 units. Now the next question, see, the distance between the points A and S is. For this, you have to say the coordinates of the point either, or you can count the distance between these 2 points. So we are supposed to find the distance between the points A and S. Look at the point A. The coordinate of A is let's say the point A. The coordinate of A is, so this is 1, and this one is 1, 2, 3, 4, 5, 6, 7, 8. So this is 1, 8. The coordinate of A is 1, 8. So the same way we have to see the coordinate of S. So count like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So the x coordinate is 17 and the y coordinate is 1, 2, 3, 4, 5, 6, 7, 8. So this is 17, 8. That means you should find the distance between A18 and the S178. You will get the distance between these 2 points. That is root of 17 minus 1 the whole square plus 8 minus 8 the whole square. So you can easily find the distance between A18 and S178. The coordinates we found A18 and the S178. So when we find the distance AS, it will be root of 17 minus 1 the whole square plus 8 minus 8 the whole square. That comes like this: root of 16 square, that is equal to 16. So option 3 is the right answer for this third question. Now let's see the next one. Find the coordinates of the point which divides the line segment joining the points A and B in the ratio 1:3 internally. Find the coordinates of the point which divides the line segment joining the points A and B in the ratio 1:3 internally. So that we can find out by section formula. Let's see the diagram again. We have to take the coordinates of A and B. A is only written, it is 1, 8. And when we take B, again, I count the points x coordinate and y coordinate: 1, 2, 3, 4, 5, 5. X coordinate is 5. And the y coordinate is the height only A, it was 8. Now 9, 10, it is 10. So 5, 11. So A18 and B511 are the coordinates. So this type of coordinate geometry questions, if a graph is given with the 1 centimeter unit, you have to observe the points and write the coordinates, and based on this one, you can easily answer the case study questions. Here we apply the section formula A18 and B511. So let's see A18 and B511. So these are like x1, y1 and x2, y2, and the ratio m1 is to m2 is 1:3. So you can find the x coordinate and the y coordinate. X coordinate will be m1 x2, that is 1 into 5 plus 3 into 1 upon 1 plus 3, m1 x2 plus m2 x1 divided by m1 plus m2. That will be 5 plus 3, 8 by 4, that is equal to 2. And y coordinate is m1 y2. So 1 into 11 plus 3 into 8 upon 1 plus 3. This 35 by 4, that is 8.5. So option 4 is the right answer, 2, 8.5 for this question. And the last subdivision of this case study question is, if the pointer xy, that one is equidistant from Q98 and S178, then. So let's take the point like this, say capital PXY, that is equidistant from Q98 and S178. If it is equidistant, PQ is equal to PS, or PQ square is equal to PS square. Then we can apply the distance formula. So it comes like this. X minus 9 the whole square plus y minus 8 the whole square. That is equal to x minus 17 the whole square plus y minus 8 the whole square. We can cancel out this y minus 8 the whole square from both the sides. So these two will go from both the sides as y minus 8 the whole square. And let's expand the remaining part. So this is a x square minus 18x plus 81 is equal to x square minus 34x plus 289. We'll cancel out this x square, and then you will be getting the answer. So let's cancel out this x square, 16, and when we divide by 16, we get x minus 13 is equal to 0. That is option 2 is the right answer for this question. X minus 13 is equal to 0. So that's all about the case study question 17, about scale factor and similarity scale factor. A scale drawing of an object is the same shape as the object, but a different size. The scale of drawing is a comparison of the length used on a drawing to the length it represents. The scale is written as a ratio. For example, we have drawn maps and we have taken the measures in maps. In the map, we cannot draw the original length. So we take, for example, for 10,000 kilometer, you will take 1 centimeter as a scale. So that ratio between 1 centimeter and 10,000 kilometers, that is called the scale factor. For similar figures, the ratio of two corresponding sides in similar figures is called the scale factor. The ratio of two corresponding sides of the similar figures. As you know, for similar figures, the shapes will be the same, but size may not be same. So one size will be smaller, so that is to the other side, the corresponding side in the bigger one, that is a scale factor. It is length in image upon corresponding length in object. If one shape cannot become another using resizing, if one shape can become another using resizing, then the shapes are similar. So if a one shape, if it can become another using resizing,
So these minute points you should note down. It may be there in one part of the subdivisions. Resizing, then the shapes are similar. So then other cases are there where we take similarity in. So there are other situations also where we take similarity. Rotation or turn, then the shapes will be similar. Reflection or flip, the shapes will be similar. Translation or slide also, the shapes will be similar. So let's say the first question. A model of a boat is made on the scale 1:4. The model is 120 centimeters long. The full size of the boat has a width of 60 centimeters. What is the width of the scale model? So since the question is to find out the width of the scale model, we are going to compare the width with the scale factor. Let's say the comparison. The scale factor is 1/4. So 1/4 is equal to the full size of the boat is 60. Full size of the boat has a width of 60 centimeters. So we want to find the width of the scale model. So I take the width of the scale model as x, that will be in the numerator, because that 1 represents the scale and 4 represent the original, the boat. So 1/4 is equal to x by 60. So we need to find the width. So no need to take the length which is given. I took only the width. So then do the cross multiplication. We get 4x equal to 60. We get 4x equal to 60, which means x is equal to 60 upon 4, that is 15 centimeters, which means option 3 is the right answer, 15 centimeters. Let's see the next question. What will affect the similarity of two polygons? They are flipped horizontally. Then we have studied polygons will be similar. They are dilated by a scale factor. Of course, the polygons will be similar. They are translated down. Then also the polygons will be similar. They are not the mirror image of one another. So then they won't be similar. So the correct option is option 4. That is, they are not mirror images of one another. Then their shapes will not be same. So this is the answer for the question B. Now question C. If two similar triangles have a scale factor of A:B, which statement regarding the triangles is true? Option A, the ratio of their perimeters is 3A:B. That is not true, because we have studied the ratio of the perimeter is same as the ratio of the sides or the length. So ratio of perimeter also will be A:B. Second option is their altitudes. It have a ratio A:B. So let's check that one. Their altitudes have a ratio A:B. You know, the altitude we can find out using the ratio of areas. Ratio of areas is area of the first one by area of the second one we have studied. It is A square by B square, square of the ratio of the corresponding sides, which means first area is half into side of the first one, that is A into H1. H1 is the altitude. Then half into side of the second one, that is B into H2, which comes like this, A square by B square. We cancel this half, and one of the A will go from both sides, B also will go, and we get H1 by H2 is equal to A by B. That is, that option is true. So the correct answer is option 2. Their altitudes have the ratio A:B. The ratio of corresponding sides are equal. The shadow of a stick. So you can see this is the shadow of the stick, 5 meters long. So stick is 5 meters long, shadow is 2 meters. At the same time, shadow of a tree, and this is the shadow of the tree, 12.5 meters is the height of the tree. So we can easily compare. If I take the shadow of the tree as x, then we'll write 12.5 upon x. That is equal to 5 by 2, which means 5x is equal to 12.5 into 2, that is 25, or x is equal to 5 meters. You can see the model, the attic floor ABCD in the model is a square. So you can see the ABCD in the diagram. So this is a ABCD. This is ABCD. So this is clearly a square. All sides are equal. So this one is a square. Now the remaining part which is written in the question, the beams that support the roof are the edges of a rectangular prism EFGHKLMN. So this is the beam EF, the beams that support the beams that support, that is EFGH, and then we have the spot K, and then L, M, G. So, and this is clearly given. E is the middle of AT. That is very important. E is the middle of AT. AT is 12. CT is 12. All sides are 12. Because at the end it is given. All the edges of the pyramid in the model have length 12 meters. E is the middle of AT. E is the middle of AT. F is the middle of BT. G is the middle of CT. And H is the middle of DT. So by keeping this in mind, we have to answer the remaining questions. Question A. What is the length of EF? Let's see EF. What is the length of EF? Where EF is one of the horizontal edges of the block. TAB in the diagram. Let's see, I will highlight the triangle TAB in the diagram. So this is the triangle TAB. So this triangle TAB and the triangle TEF, these two triangles are clearly similar triangles. So we can take the ratio of edges. That is, we want to find the EF, T by, since they are similar, T by TA is equal to EF by AB. Except EF, the remaining parts are given. T being E is the midpoint, T is 6. So 6 by TA is 12 is equal to EF by, and AB is also 12. And we can find EF. So 12 and 12 will go. So EF is equal to 6 meters. That is option 3 is the right answer for this question. Here ends question number 18, the case study question 18. It's based on applications of parabolas from quadratic polynomials, highway overpasses, underpasses. A highway underpass is parabolic in shape. You can see the highway underpass in the diagram. Then a description about parabola is given. A parabola is the graph that results from P of x equal to ax square plus bx plus c. That is a quadratic polynomial. Parabolas are symmetric about vertical line. So this is the vertical line. It's symmetric about the vertical line. This is known as the axis of symmetry. The axis of symmetry runs through the maximum or minimum point. So this is the maximum and this is the minimum point. So the axis of symmetry that runs through the maximum or minimum point. Parabolas are symmetric about a vertical line known as the axis of symmetry. You can see the axis of symmetry in the diagram. The axis of symmetry runs through the maximum or minimum point of the parabola. So here you will see a maximum point in this shape, and this is called the vertex. So the maximum point in the above figure is the vertex. And in the next figure, you can see a minimum point. So in this one, it's a minimum point, that's a vertex. And in this type of parabola, it is the maximum point, and that is also called the vertex. So here it is the maximum point. Two terms are explained there, axis of symmetry and the vertex. So based on this one, we have quadratic polynomial type questions. If the highway overpass is represented by x square minus 2x minus 8, then its zeros are. It's very easy. We have to equate it to 0. The usual method of finding the zeros of a quadratic polynomial. That is x square minus 2x minus 8 is equal to 0, which means sum of zeros is minus 2 and product of zeros is minus 8. So you can see the two numbers minus 4 and 2, that is x minus 4 into x plus 2 is equal to 0. When you factorize this, so x is equal to 4 comma minus 2. So option 2 is the right answer. Second question. The highway overpass is represented graphically. Zeros of a polynomial can be expressed graphically. Number of zeros of polynomial is equal to number of points where the graph of the polynomial, option 1 intersects x-axis, option 2 intersects y-axis, option 3 intersects y-axis or x-axis, none of the above. So since the polynomial is given in x, p of x is given, we can clearly write it is option 1 intersects x-axis. Let's see the third question. Graph of a quadratic polynomial is a parabolic shape. It is already given in the paragraph as well. Graph of a quadratic polynomial is parabolic shape. Option D, the representation of highway underpass whose 1 0 is 6. Let's take alpha is equal to 6. And sum of zeros is 0. Sum of zeros means alpha plus beta, that is equal to 0. That is 6 plus beta is 0, or beta is minus 6, that is the second 0. You know the quadratic polynomial x square minus sum of zeros into x plus product of zeros. X square minus sum of zeros is given 0, so 0x, and product of zeros is 6 times minus 6, it is minus 36. That is option 2 is the right answer, x square minus 36. Then the last one, the number of zeros that polynomial f of x equal to x minus 2 the whole square plus 4 can have is, being a quadratic polynomial, it can have at most 2 zeros. So option 2 is the right answer, 2. So that is all about question number 19. Then we have one more case study question, that is question number 20, which is based on statistics in this paper. Let's see the case study question number 20. 100-meter race. A stopwatch was used to find the time that it took a group of students to run 100 meters. The table is given with time in seconds and number of students. 0 to 20 seconds, 8 students. 20 to 40 seconds, 10 students. 40 to 60 seconds, 13 students. 60 to 80 seconds, 6 students. 80 to 100 seconds, 3 students. Based on this table, we should answer the statistics-based questions. The first question is, estimate the mean time taken by a student to finish the race. You know, the mean is sigma fi xi by sigma fi. So let's see, sigma xi means we have to take the xi values. This is 10, the class mark 0 plus 20 by 2, and then 30, we have 50, then 70, and then 90. So mean is sigma fi xi upon sigma fi. Sigma fi, let's add this one. So 10 plus 8 plus 13 plus 6 plus 3. So that comes 40. 40 is the total. And sigma fi xi means 10 into 8 plus 30 into 10 plus 50 into 13 plus 70 into 6 plus 90 times 3 upon 40. So when you multiply, it will be 1720 upon 40. So answer will be 43. So the mean is 43. That is the first answer. The mean is 43 for this question. 43 is option 3. Second question, what will be the upper limit of the model class? You know, the model class is the class corresponds to the highest frequency. Here the highest frequency is 13. Here the highest frequency is 13 and the class is 40 to 60 and the upper limit of 40 to 60 is 60. So the answer is option 3. 60 is the answer. That is the upper limit of the model class. Third question, the construction of cumulative frequency table is useful in determining the median. Cumulative frequency table, we can find out the median. Next one, the sum of lower limits of median class and model classes. Only the model class is done. Model class is 40 to 60. Now we have to take the median class. So let's see the median class. For the median class, we need to write the cumulative frequency. So the cumulative frequencies are 8, then 8 plus 10, 18, then 31 plus 6, 37, plus 3, 40. So the sum of frequencies, sigma fi is 40 or n is 40 and n by 2 is 20. Now we have to see the cumulative frequency which is greater than and nearest to 20, that is 31. Its corresponding class is again 40 to 60. So the median class is also 40 to 60. Median class is 40 to 60. And then we should add the lower limit of median class. Lower limit of median class is 40. And the lower limit of model class is also 40. 40 plus 40, 80 is the answer. The last question, How many students finish the race within 1 minute? 1 minute means 60 seconds. Again, see the table. So this is 60 seconds. So less than 60, you can see the corresponding cumulative frequency either, or we'll add 8 plus 10 plus 13, that is 31. So the number of students who finish the race within 1 minute or 60 seconds is 31. That is option 3, it is 31.
That's all about the case study questions of standard question paper. In the next video, I will explain the case study questions of basic question paper. Thank you for watching.